Morning, folks. I'm Dave Canterbury with Self-Reliance Outfitters in the Pathfinder School, and I'm back down here at the Pathfinder Outdoor Classroom. What I'd like to do today is I'd like to explore the new BRUNTON H3 Tritium Lensatic compass. And this is a military-style Lensatic compass. I've done a couple videos involving this compass on my channel, but I wanted to kind of talk specifically about this BRUNTON H3, some of the distinct advantages and disadvantages between the Lensatic compass and the base plate compass. And I think it's important as well-rounded woodsmen and outdoorsmen or outdoors women that we understand the Lensatic and the base plate compass so that we can use either if the need arises and understand which one may be better for certain applications so that we can switch between the two fairly easily if needs be. Today, we're going to cover all of those topics. Stay with me. Okay, so before we get started too far, let's first discuss the component parts of this BRUNTON H3 compass. To open this compass, you would pull the thumb loop backwards, open the cover, and then you would lift the sighting arm where the sighting slot is, and it releases that internal card so that it can move freely. You have a magnetic north needle that's luminous, and this compass is lit by tritium, which is a radioactive material. And you can see that it has a radioactive warning on the back. And tritium is radioactive, so it glows without being recharged. You don't have to hold light against it like a normal glow-in-the-dark piece would be to get it to light up. It lights up automatically in the dark. And I'll put some footage of this compass in a box so that you can kind of see the areas as we talk about them that glow on this compass. So starting at the back of this compass, as I said before, we have a thumb loop, and that thumb loop is used to get a good hold on this compass for taking bearings and sighting bearings. We'll talk about that in a few minutes. You have an arm here that has a couple components on the arm. It has, number one, a magnification lens here for reading the dial. And you have a sighting window here that lines up with a sighting wire here, which also has luminous slots here and here so that you can see them in the dark. And then you've also got some areas lit up east, west, and a window here that are also lit with tritium. And you have a north arrow that's lit with tritium. Okay. Now, you have a bezel ring on this compass that moves in clicks. We'll talk about the clicks here in a few minutes, but it has a short luminous line on it. Then you have a black line here that's called an index line. It does not move. It stays at the top of the compass facing in a forward direction. You have a straight edge on this compass here that in this case is set up for 1 to 50,000 maps. You have a base, which is just the base of this device right here, is the base. You have a cover, which is what we unfolded to open the compass. Okay, so inside the housing of this compass, you have the floating dial, okay? And the dial in this is a card that floats, and we'll talk about that in a few minutes. It is independent of the bezel ring, unlike a normal base plate compass. It is divided into two scales. The red scale is 0 to 360, and the black scale is 0 to 6,400 or mils. You're broken up into 5-degree increments on the red, 20 mil increments on the black. Each click of this bezel ring represents 3 degrees as you move this luminous line, and we'll talk more about that in a few minutes. Now, it's very hard to show this on camera, but this magnifier is tilted forward enough so that you can get a clear view of the numbers on the floating card. And that's how you're going to read your direct azimuth, okay? So I wanted to cover that real quick and get a close-up of it before I show you this far away. And you're going to use this sighting window and this sighting wire to line this up on your azimuth, and then it will be a direct read, and the number that you read at the top of the compass through this magnifier is your azimuth. All right, so to shoot an azimuth with this compass, instead of holding it out at full presentation like you would a base plate compass, so that you can reduce the field of vision within the V-sight to get accuracy, with this you have a very thin sighting window here. You have a sighting wire here between the two luminous points, and the magnifying glass is adjusted to read the internal card that's moving. So what you would do is you would put your thumb in the thumb loop and get this nice and square on your hand, lift the sighting wire up so that you can look through this sighting window into the wire to point this directly at what you're trying to aim it at, closing your non-dominant eye. And you would adjust the magnifying glass so that you can see the bezel ring and read the number on the bezel ring. And that gives you what's called a direct read or direct azimuth. So whatever that number is on the card, that's the azimuth that you're traveling. If you want to effectively put needle in the doghouse to travel over distance or leapfrog, what you need to then do is move the bezel ring, which has only one line on it that's luminous, that moves with the bezel ring, and you need to move it until it's over the top of wherever your luminous line on the magnetic needle has landed. And then you would have what's called needle in the doghouse. And I'll give you an example of that over the top. So if we've taken a direct read azimuth here and now we want to get needle in the doghouse, we're just going to move this luminous line in line with the luminous line here. And as long as we don't move, we keep our needle in the doghouse and we're walking a straight line, very similar to a base plate compass, except for the fact that this one does not have a bezel ring that moves the degrees. The degrees are on this internal card. And so your degree reading is in line with a black index line, and the bezel ring just moves independently, and you move it to where it is over the top of your luminous arrow that's pointing magnetic north, and that's needle in the doghouse for travel. But your direct read or your bearing is whatever number's at the top here in line with the index line. You've got a window there that glows in the dark as well so that you can see those numbers at night. All right, the other method we can use with this compass, not bring it up to our eye, if we don't need that extreme accuracy, is we can use the center hold method. And we just hold the compass at about waist level, taking a good center hold both sides of the compass like this and holding it in the center of our body, obviously away from any belts, rings, and all those types of things that are metal that may affect the compass. Point it in the direction we choose to travel. Move this outer bezel ring until the luminous line is over the luminous line on the north side of the card. We have needle in the doghouse at that point, and we can then walk that azimuth. If you don't need extreme accuracy, this is an easy way to use this compass. If you need the extreme accuracy, then you have it by using the thumb hold method here. Okay, let's discuss this card inside here and how this thing is set up and moves. First of all, there's no liquid inside this housing, which is an advantage over liquid-filled compasses because you never have to worry about getting a bubble in there. You never have to worry about the liquid leaking out or any of those things. It has a rare earth needle floating on a sapphire bearing with a copper dampening pan. It comes in Northern Hemisphere and Southern Hemisphere versions. It is not universal. There is no global version of this compass, okay? But it is a very complicated mechanism that's set up to U.S. military specs and standards and has an NSN number for sales to the U.S. military. Okay, this compass also comes with a ballistic nylon case with a snap on the front, and you can use this Alice clip to attach to your gear, or you can put MOLLE straps through this thing as well, or put it on a belt. It's got several ways to attach this to your gear or to your person, and again, a nice heavy ballistic nylon pouch. All right, let's speak to this bezel ring for a minute. You can hear it click as it moves, all right? And one click of this bezel ring is equal to 3 degrees. So 3, 6, 9, okay, and so on. And you have a glow-in-the-dark line there moving as you move the bezel ring. That gives you lots and lots of advantages that we're going to discuss in the next few minutes, all right? Because this compass has tritium in it, and it glows in the dark all the time, whether you've charged it or not. You can take it out of a black hole in your pack somewhere, pull it out at night, and it's going to glow. It gives you greater advantages for night navigation, especially if you don't want to turn your headlight on to recharge your bezel ring, you don't want to blow your night vision, or for any other reason that you don't want light on when you're navigating at night. This compass definitely has huge advantages for that. The bezel ring that clicks gives you even greater advantages when it comes to changing directions and knowing what azimuth you're actually operating on very easily. Okay, so now let's talk about these clicks in this bezel ring and talk about the advantages of that and the disadvantage that this compass has compared to a base plate compass in accuracy, okay? And the problem with this compass is, and I don't consider it a problem necessarily, unless you were trying to navigate a very, very long ways, but if you look at this compass, the card is divided in 5-degree increments. The clicks of the bezel ring are in 3-degree increments with each click moving that luminous line, all right? Most base plate compasses are divided into 2-degree increments. And if you get between those two lines, you could get to 1 degree of accuracy fairly easily. So you're not gonna get the accuracy from this compass in degrees that you can get from a base plate compass. In mils, you can get quite a bit more accurate. In degrees, not so much, okay? So this compass, while it has faults, also has a huge advantage with the luminous lines and the tritium and the clicks for being able to change an azimuth or dial in an azimuth on the fly without having to see the compass physically or look at the dial. So if you are trying to do something at night and you want to change your azimuth, you can do that very simply just with the clicks, by feel and by sound. If you're moving during the day and you have bad vision, your vision's not really good, you wear reading glasses and you lose them or something like that, if you can see the luminous line enough to get it to the top on the index line, that's really all it takes to be able to dial this thing in. And as long as you can see the luminous line under the luminous line, you're gonna be in good shape. You don't need to see the very small numbers necessarily to navigate with this compass. So let's talk about that and how that works, all right? So again, starting out with this from 0, we would want the luminous line on the bezel ring directly over the top of the black index line. And I can see that without my glasses on. I can in no way, shape, or form see these numbers, but I can see everything else from a distance. I can see east, west, north, south, luminous lines. I can see the black index line. I can see all of that without my glasses on, okay? So now, let's say that I want to travel on an azimuth and plug it into this compass. What I need to understand is that if my azimuth is less than 180 degrees, I'm going to divide whatever number that is by 3 because each click is 3 degrees. And I'm going to move my bezel ring counterclockwise, this direction, counterclockwise. So I'm going to go this way, 3 degrees per degree. If my degree reading or my azimuth is over 180 degrees, what I'm going to do is I'm going to subtract that number, kind of like a reverse azimuth, from 360 and get the difference, and I'm going to move my bezel ring clockwise, okay? So let's do that real quick and kind of test that theory. So let's say we want to travel on a 60-degree azimuth. 60 degrees divided by 3 equals 20 clicks, all right? We know that 60 degrees is less than 180, so we're going to move counterclockwise. So now we can take our compass from 0 here, without our glasses on at all, and just go count clicks, not even look at it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, okay? I've counted 20 clicks. I've moved that luminous arrow 20 clicks, and I've moved it in a counterclockwise direction. And now I can have faith that once I put needle in the doghouse and the luminous line of this compass is on the luminous line here, which I'm going to be able to see even without my glasses on, I'm on a 60-degree azimuth. And I can tell you now that 90 is right here. So I know that's pretty close to 60. Now I'm gonna put my glasses on, I'm gonna look. It is actually dead on 60. Dead on 60. So, very, very simple. Now let's look at one the other direction, okay? And work on that. So we'll take this luminous line and we'll move it up. Again, I don't need my glasses to see that. Straight up and down, all right? Let's say this time we want to move to 240, all right? We take 240 from 360, that is 120, divided by 3, 40 clicks. All right, 40 clicks. Now, this time, we're on this side, we're going clockwise, remember that, okay? If we are more than 180, once we divide by 3, we're going clockwise. So now, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 40. Let's see where we're at. We should be at 240 degrees when we put the needle in the doghouse. We are at 240, right on the button, okay? On the red dial. So it's that simple to do this without even looking at the compass and having faith in it being there. Now, here's another trick I would tell you. Depending on the amount of clicks you've got here. You can see that this click right here was 40 clicks, all right? And we know that we're going clockwise. Remember that 30 clicks is 90 degrees. 90 divided by 3 is 30. So on this one where we've got 40 clicks to go, 30 of those clicks is going to be this or this, all right? So if we know we're going clockwise, we could just take this thing and go clockwise right to the 90 degrees right off the bat. And we can see that. We can see that 90 degree angle even without glasses on. I can see that 90 degree angle. Then I only have to go 10 more clicks, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Needle in the doghouse. Boom, 240 again, okay? So we can shortcut that so we don't have to count so many clicks by understanding these quadrants, right, are 30 clicks. So if we've got something over 30 clicks, we can move an entire quadrant clockwise or counterclockwise and get most of the way there so we're not having to count so many clicks. A pretty simplistic way of doing it, very reliable way of doing it as long as you are correct in what you do. And you can navigate at night or navigate in low visibility, or if you have problems with your vision and you can only see things, you're not nearsighted, but you're a little farsighted. This compass has huge advantages in those cases. Because most of the time, if you're farsighted, if you get that magnifying glass up against your eye good enough, you know, even without my glasses on, I can take this, and these are 2.0s right here, but I can take this thing and I can go without my glasses on and get it in a position where I can actually read that dial. Right there, almost straight up and down, I can read that dial. I'm reading 120, 135, 135 right here, okay? 180 is right here. So I know that's about right. So even if you've got problems with your vision, this compass may help you out a ton, whereas other compasses, you're going to have to be able to see what you're doing to be able to make them operate accurately. All right, guys, appreciate you joining me out here today for this video on the H3 Lensatic compass from Brunton. A few tips and tricks there at the end. I think this compass is definitely worth owning. I think it's worth understanding. Even if you prefer a base plate compass, it's definitely worth owning and having a Lensatic in your toolbox. I appreciate your views and I appreciate your support. I thank you for everything you do for our school, for our family, and for our business. For all of our sponsors, instructors, affiliates, and friends, and remember to visit selfrelianceoutfitters.com this 4th of July weekend because we do have a sale going on and there's some really, really good deals to be had this weekend. Happy 4th of July. Happy Independence Day. Enjoy the fireworks, guys. I appreciate everything you do for us, and I'll see you on the next video. Thanks, guys.